Let's dive into a classical geometry challenge. We are looking at a rectangle inscribed inside a circle with a radius of 10. Our goal is to find the total area of that rectangle, knowing that its diagonal forms a 30-degree angle with a longer side. We start by visualizing the circle. With a radius of 10, the center point is our anchor. The single value of 10 is the key that unlocks every other dimension in this problem. Now, we inscribe the rectangle. When we draw the diagonal from corner to corner, notice something important. Because this is an inscribed rectangle, the diagonal must pass through the center. It is actually the diameter of the circle. Since the radius is 10, and therefore our diagonal is exactly 20 units long, we are now moved from a circular measurement to a linear one for our triangle. That 30-degree angle at the base tells us exactly what kind of triangle we are working with. A 30-60-90 special right triangle. This is one of the most powerful tools in the geometry because of its fixed ratio. Here are the ratio x square root of 3 and 2x. These defines the relationship between the short leg, long leg and the hypotenuse. Let's map them. First, the short side opposite our 30-degree angle. That's our height x. Next, the longer base opposite to 60-degree angle. That is x square root of 3. And finally, the hypotenuse, which we already know is our diagonal. That represents 2x. Now we simply solve for x. If 2x is equal to our diagonal of 20, then x must be 10. This allows us to instantly find out our real world dimensions. Our triangle height is 10 and our base is 10 square root of 3. We have everything we need to find the area. The area of a rectangle is base times height. So we multiply 10 square root of 3 by 10, which gives us the final answer of the area, 100 square root of 3.
If you like the video, follow and subscribe so you never miss the daily SAT challenge videos.